Hello, in this video we're going to take a look at some of the basic concepts behind model railways. We'll show you some of the basic elements and what you need to do to get started. So this video is geared towards a beginner who's looking to get a little bit more information. So the first thing I'll start off with is this is obviously a piece of track. I'm not sure if you can see there in the videos, but the track actually in the sleepers between the rails here have little holes, and these holes are actually for track pins. So after you've done testing your layout and you're happy with it, use these track pins in the hole to secure the track to your baseboard. And a couple of reasons you want to actually secure it. As the trains go over it, if it's not secured, the track will move, and over time you lose connections here. You may also end up with derailments, especially if you're using FlexiTrack. So it's best to basically nail down your track as soon as you can. So how you connect the track together are with these little pieces of metal called fish plates. And if you're in the States, I think these are called rail joiners, but mostly in the UK, these are known as fish plates. And it's a pretty simple task. You can see here there's a slot for the rail, and depending on the type of fish plate you have, there may be a little kind of larger piece on the end to help get it on. And it's quite simple. You just hold the rail, put the piece on like that, and just wiggle it a little bit. Now if you are using FlexiTrack, and you can see here this is a piece of FlexiTrack, and the fish plates won't actually stay in place, so you'll have to eyeball it, and you may end up having to hold the rail down to connect the adjacent track to it. But the Hornby track, this is a sample Hornby curve here. I think it's the first radius curve. And the Hornby track, if you're not buying FlexTrack, if you're just buying the regular single pieces, they actually come with the fish plates already installed on them. There's one here on the left hand side and one on the left hand side on this end, and basically you just clip them together. But if you are using FlexTrack, you need to put the fish plates on it yourself. So as you hear me talking about FlexTrack, I'll actually show you a piece. FlexTrack is actually sold in various lengths. This is actually a flexible track. They also sell a semi-flexible track, which is a little less flexible. And basically what you do is you have a large length. If I pan it down here, you'll see it's about halfway. It's quite a long piece of track. Can't remember off the top of my head how long it is. I think it's maybe a couple hundred millimeters, maybe 600 or 900 millimeters. And basically this will bend. If you see here, as it bends, one rail gets shorter, gets longer, or if it's straight, they'll remain pretty level. And basically what the idea behind the FlexTrack is that you can actually shape it into any form that you need for your layout. So rather than being stuck to specific curves or specific lengths, you can cut this or use it straight as is, depending on your layout. Now what you do if you do need to cut it, and I'll demonstrate later in the video how we go by doing that. We actually use a tool called a Dremel. But basically once you cut the rail, if it's curved, obviously one end will be longer than the other, so you'll need to cut this so they're straight. But to get the sleepers right, the sleepers actually clip. Sure, it's not too easy to find, but there's usually a little arrow with the clip in it. Maybe under the sticker here, so I'm gonna just remove the sticker. Yep, there it is. So I'm sure you can see it on the video, but right there's a clip, and these sections will actually unclip. I'm not actually going to do it, but when you unclip these, you can then cut how many pieces you need out, and then push them back together and reclip, and it takes up the slack out of the flexible track. So that pretty much covers the basics there. What I'm going to show you is that the track pins actually come in different sizes. This thinner track pin, if I line them up, it'll make a little more sense what I'm saying. But here you can see they're in different lengths. This first thicker but shorter one is actually a Hornby. It's a Hornby track pin. These are actually a little bit trickier to get through those holes. They do a better job at securing the track, and once they go in, they're really hard to get out, and the track doesn't move very well, which is good. However, it's pretty hard to get it through a hard surface like the this plywood here. The smaller one in between here is a little thinner. It's actually an American brand. It's Model Scenics. I like these ones particularly because they just go through pretty much anything pretty quickly and without too much hassle, and they're not easy to bend, which is a plus. Now, unlike the Hornby ones, I can't even bend them if I try, so that they're pretty strong. But because they're inflexible, they don't really go well, especially if you've got a hard surface underneath. In fact, I've had a couple of times where they'll actually break the sleeper as opposed to going in straight. And finally, this is just a generic brand that I got off of Hatton's. I think it's Javin Scenics or something like that. And these are actually pretty good. They're a little bit sturdier than the American Model Scenics ones, and they're a little bit longer. And as you'll see later in later videos, in parts of the layout, I've actually used recycled some business cards to fix the elevation problems in a few places, and to insulate against some screws that were used to assemble the baseboard. And these actually go really well straight through those because they're a little sharper on the end. So I would highly recommend these from Hatton's, and they're pretty cheap. I think they're like £1.50 or £2 for a decent sized bag of them. So another piece of information that might be useful to beginners is you'll see, especially if you go beyond the basic Hornby and Pico set track, there's tracks actually coded. You'll see there's code 100, code 75, and there's also code 83 that's used in the States. Basically what this code refers to is the actual height of the rail. So if you're looking at the rail like this, it's the distance from the bottom of the rail to the top of the rail in 1/1000ths of an inch. So code 100 is actually 0.1 of an inch in height, and so if you've got code 75, it'll be 0.075 of an inch. So that's no, you're not talking very big height differences, but the fine scale is preferred by a lot of modelers who've been doing it for a while. So I think it's closer to scale, but code 100 is usually it's pretty easy to work with, and for beginners it's good way to go. And one other thing too, if you're dealing with older models, the older models do not like especially the Triang and the Hornby Railways models from the 50s, 60s, and 70s. They have much deeper wheel flanges. If you look at some of the other videos on our channel, you'll see we discussed that. I think in the Lima HST Light project, I talked about it with the dock shunters. But because their wheel flanges are so deep, they work okay on the code 100 track, but they just can't make it around the code 75. And to give you an idea why that is, this is actually an old piece of Series 3 track, and if I put it side by side, you can see there the obvious height difference. The code 100 modern track is on the bottom, and the much thicker tri-ion track is on the top there, and you can see it's a much bigger height difference, and because of that, a lot of the trains will run on the newer track. So if you have a lot of older stock, you might want to stick with the Code 100, and it's pretty decent track. It's what I use here. One other thing too that you probably want to know is even though the UK trains are all dolo scale, they actually use HO scale track, so you can use track from Atlas and other companies as well if you're over here in the States or can't get your hands on Hornby track. So if you're trying to figure out what a piece of track is and maybe you're not familiar with it, if you actually flip the track over, most brands will put their product number, name of manufacturer, and where it was made. So here this is a Hornby R608, and it was this particular piece is a newer piece, so it was made in China. And this piece here is a Atlas 15-inch curve, and you can see there it has the Atlas name, the 15-inch radius, and the curve, and this one's actually broken. So one of the things I want to just show you here is the slight difference between the Hornby and the Atlas track. They're pretty close. This is a first radius curve Hornby track, and this is a 15-inch radius curve Atlas track, and just two small differences. One, the Atlas track doesn't actually have the built-in fish plate, so you have to stock up on fish plates if you're building with the Atlas track. Whereas unless you're using flex track, if you're just using regular Pico set track or the Hornby track here, you don't have to worry about it because they have the built-in fish plates. The only exception is, like I said earlier in the video, the Hornby flex track does not have the fish plates, and the reason. One of the key differences with Atlas and Hornby track is the curve is slightly different. So the first radius track here is 371 millimeters, and basically what that means is if you were to take several pieces of this track here and make a circle about for it, and the distance from this end of the circle to the other end of the circle, the radius or the diameter, radius is half the diameter, so that quarter arc would be from here to the center of the circle would be 371 millimeters for its first radius track. For the 15-inch Atlas track here, it would actually be 15 inches to the center of the circle, so it would be a total of 30 inches from one end to the other, and that actually turns out to be 381 millimeters of radius. So as you can see here, there's just a slight difference. The Hornby track is there on the bottom, and the Atlas track is on top. And if I hold it like that, you can see there's just a slight difference. It's about I think it's 10 millimeters of a difference in the radius. So this Atlas track actually comes here in the States in a couple of different sizes for the curves. There's 15-inch, there's 18-inch, there's 22-inch, and there's 24-inch. The Hornby track comes in first, second, third, and fourth radius track. And what's interesting is the Hornby track is, or the Atlas track is actually almost an intermediary between the different sizes. So, for example, the smallest radius you can get is first radius, and that's like I said, 371 millimeters. The 15-inch radius track is 381 millimeters. The second radius Hornby track is 438 millimeters in diameter, or in radius, and the 18 inches from the Atlas folks is 452.2. Oh, sorry, it's 457.2. So you can see there it's only off by 10, 20 millimeters, and the third radius track is 505 millimeters, and then the 22 radius track, or 22-inch radius track, is 558.8, and then finally the fourth radius track is 572 millimeters, and the 24-inch track is about 609, 610 millimeters. So as you can see, the American track is just a little bit one size, a few millimeters wider. So depending on your layout, you may be able to mix and match the curves inside loops to get a better setup. You might be able to fit more tracks, for example, inside a tight space. First radius track probably shouldn't be used. It's okay for some older tank engines, but a lot of the newer stock just won't go around. It's too tight of a curve and will either derail or otherwise have some sort of problems like detail catching on the sleepers and so on as it tries to go around the curve. So I think the next section will be power clips. So the Hornby controller, if you're familiar with it, you're probably familiar with these really annoying power clips. And while these things are okay for beginners, these get really annoying fast. And basically the way they work is there's two terminals there, and they end up touching the inside of the Hornby track to make a connection. So if I show you a piece of Hornby track here, they actually have a set piece where the sleepers aren't there, and basically one side goes in under the track like so, and it can be challenging to get it to work, and it's kind of annoying, but basically they end up touching against the rails like so. Now what can happen over time is these get bent and they don't make contact with the track properly. So one option, I guess, if you have these is to use them as a soldering point and solder them directly to the track like so. But I prefer to basically get rid of these. Here's the power end of the controller that actually fits into the socket like so. But as you can see, I actually cut these off. And you're probably familiar with the regular Hornby controller here. And so what I've actually done is cut the connector off, and then we solder these directly to the rail. So you solder one to one rail, one to the other. If you have a more complicated layout, you want to make sure when you solder these up that you solder the same direction on both tracks. So if you have connecting tracks with insulated fish plates or something like that, you want to make sure that they're wired the same way. Otherwise, when you run the train from one track to another, you'll actually have to run them in opposite directions if they're reversed in polarity. So it's usually a good idea to keep the whole layout wired properly in the same polarity. Now, this is actually a DC controller, and you've probably seen DC and DCC controllers. And basically, what a DC controller is it takes power in. This is actually a 16 volt AC in, and it outputs 0 to 12 volts in DC. So you don't want to connect your trains or your track directly to the AC power. You'll blow them up. But these run off DC. And basically, it's pretty simple. You set the controller one way. You have voltage. Set the controller the other way. Reverse voltage. And it's as simple as that. Now you also have DCC, and DCC is a little bit more complicated. What it does is it actually sends a signal digitally down the wires to the trains, and the trains actually have some electronics on board, and it's actually a pulse mechanism. So there's the ones and the zeros are communicated through slight variations in the actual DC current itself, and that causes problems for older motors. It can actually wear them out a little faster. So if you have older stock, you might want to stick or at least have one section configured for DC, and I prefer DC over DCC. I know you can run multiple trains with DCC, but there's ways to do that with your layout if you design it properly. So it's a bit more of a challenge and keeps things a little bit more interesting to stick with the DC. Now, the newer track is coated with something called or made from material called nickel silver. I'm not sure if it actually has silver in it, but the reason that this material is better than regular steel or iron or other metal is it doesn't oxidize or rust very easily. So you end up with not too many, at least one less problem in terms of keeping your track clean. The older track, though, as you can see here, will rust over time. So you can see here it's this piece of track is actually rusted, and you can't clean it up. You can sand it down and so on and get it somewhat clean, but the newer track is just better in terms of being a little bit finer scale and not so much prone to rust. So another important aspect of model railways are actually points, and this is a right hand point, and the way you tell whether a point is right hand or left hand is you can cheat and look at the code underneath, or if you're holding it straight like this with the straight edge along the bottom, it's whether the thing is pointing to the left or to the right. So here on this right hand point you can see the this particular track here is going off to the right, so this is a right hand point. And basically you can interconnect two tracks together using two sets of points. So for example, here we have two right hand points and they interconnect together like so. And so these are manually driven, so you just flick it over and the train will go this way, and you can line them up like so, and you just have to make sure that both of them are switched the right way. Now most of these are actually just regular Hornby points, and most of them actually work pretty well. They, even if you forget to do this, the force of the wheels will cause it to flick over. But it's probably best not to do that, because you can, this piece of metal here in particular can get pretty messed up and it's not that strong. So there are two type of points that you can get. They're insulfrog and electrofrog. And basically, to keep it simple, insulfrog points basically have the track insulated when it's not wired up or not connected. So for example, here the train's going to go straight, so this track here does not have power. When you flick it this way, this track is the way the train's going to go. This has power. This is now isolated and does not have power. So the key difference there between that and an electrofrog point would be that both of these would be live. So regardless of which way you have it set, both tracks would be live in the electrofrog. So depending on what you're doing, if you have a DCC layout, these isolated tracks don't work very well. The reason for that is the trains are controlled by computer controls. So the signal is going down the wire or down the track to tell the train which decoder it's talking to. So each train has a code number. You type that code number into the controller, and it tells it signals the correct one. So when the decoder on the train detects that it's its number that you're sending the signal to, that's how you get power. So obviously, if something was an insulated track, it was isolated out here, and that signal wouldn't get to it. So that's why you have these little clips that break the isolation and for DCC layouts. So we actually use DC on our layout here, so we're not too concerned about that. And if you design your layout correctly, you can actually benefit from using these isolated tracks. So you can use them in sidings and in TMDs and depots and so on platforms to isolate and control different trains. So for example, if this was in a siding, I could have this train powered and control it, and then take it back in, and then flip the point over and take the train that was on this track and take it out onto the main line. So there are some benefits to this this type of design. And like I said, if you want to connect some points together to connect tracks, you can do so pretty trivially like this. There are also a couple other types of points. These are actually pico points, I think. Yeah, these are pico points, and these two are also isolated, so they're insulfrog. And this is actually a Y point. So if you look at it side by side there with the other one, you can see it veers off into a Y shape instead of off to the right like that. And these particular points are very handy for platforms coming into stations, to split a track, and also in TMDs and other places like that. So I like to use those in those particular areas. And Pico actually have a very nice selection of points. As you can see here, this is a more complicated point, and it's a three-way point, and it allows you to model some more complicated stuff. And what you can do with these points is use point motors. Now, I don't actually have any point motors set up on the layout yet. I haven't gotten that far. So in a later video, I'll discuss point motors. But basically, what a point motor is that it's a mechanical device. So when you flick a lever or push a button, it does this motion for you. So it actually sets or resets the track to like so, but it does it automatically, so you don't have to walk around and do it yourself. And point motors are pretty easy to set up. You can see there's a little pin hole in most of the surface mount ones. They'll hook in under that pin and flick it back and forth. So finally, I thought I'd go over some basic tools that you need. Before I discuss the tools, this is actually a buffer stop, and you put this into the track. In fact, if I pull over a piece of track here, it's pretty straightforward. You put these like you would see in real life on the end of sidings or end of platforms, or sorry, at the end of the track at a platform and station. And these basically stop the train from going off the end of the track. And if you look there, there's a clip and clip there, and then this bit goes inside the track. So you try to avoid the little plastic lips there on the holding the sleepers in, and it clips into place like that and drops right in. So you can see there, these clip onto the track and are held in place. Then this bit clips on the inside. So there's 4 pieces here that clip on the outside, and then 2 that clip on the inside, and then actually it's pretty solid, so if I hold that, it's not going to go anywhere. So if you run the train into it, even at pretty decent speed, it's not going to come off the end of the track. And obviously it's another good reason to nail your track to the baseboard. And so these are buffer stops, and this is just a cheap Hornby one. And even if you don't want to spend the money, you can actually build these with matchsticks if you're so inclined. So if you have some matches there, once they're used up, you can recycle them and put them to use. And this here is the key tool for any model railway layout. It's a standard Hornby track eraser, and basically all you need to do is take one end of it and just rub it up and down there, the track, and you probably, I'm not sure it's that easy to see from the video, but you usually get pretty good results. Don't get any tarnish off of it. And so you can do it this way, or you can take it like this and just run it up and down. So if you don't buy anything else for your layout, getting a couple of these is probably a good job, and you can get these off of hands. You can get other kinds. This is Gauge Master one that I got from somebody, and these aren't too bad. The only problem with these Gauge Master ones is they're more foamy, I guess, and as you clean the track, they just kind of disintegrate, so you end up with lots of little black pieces on the track. So it's I prefer the Hornby ones. They don't disintegrate like that. Obviously, for the American folks, that we call this a track eraser for obvious reasons. That has different meanings here in the States. So outside of the track eraser, another good set of tools is basically having a set of small screwdrivers, either for taking models apart or for just trying to get track pins back out. In fact, I use the penknife or Swiss Army knife to get the track pins out. I use the small blade, and you can get it under the track pin like that and pry it up, and you do less damage to the rails and to the sleeper. Kind of take some force off of it, because if you use a screwdriver to get the thing under the sleeper, you sometimes break it. Some of the other tools that we use on the layout is a standard tack hammer, and this is pretty simple. It's actually one I got here in the States, and it's pretty nice. It's got this larger end that just happens to fit right inside the sleeper there, as you can see. So actually fit in between the rails, and then so it's good for doing that first initial tap, and then you can tap down with the smaller piece here to avoid doing any damage to the track. So it's a pretty nice tack hammer. I think it was only a couple of dollars, maybe $10, $12. And finally, the tool that we use for cutting the track and doing other kind of modifications to it is this. It's a Dremel power tool. This is one I've had for a while, but I think they run about $30, $40. I'm not sure how much they are in the UK, but it's a pretty handy tool. We have these cutting discs, and you can basically push this button in. It comes with a kind of a spanner or wrench type tool, and you can remove this section right here and replace it with various different accessories. So I use this cutting tool, mark off the track like that, and basically cut it like so. And it takes a few seconds to cut through it, but the nice thing with this tool is you can change these blades out, so it's not that sharp, so you don't have to really worry about getting injured. You just want to keep your fingers out of the way because it runs pretty quick. And this particular model is I think it's a more expensive model, so it actually has two settings. It has a low and a high setting, and I usually cut track on a low setting. And the nice thing with this too is that if you do happen to cut it at an angle, you can use the sanding tool to level it out and get it flush. It's also good for sanding down connections once you've actually soldered to the track. So this is an indispensable tool, at least it has been for this particular layout project. So in the next segment of the video, we'll show you how to cut track with this particular tool. And here in the video you can see I've actually used some large pico points in this section instead of the regular Hornby points. And the reason I did that was these are actually areas where the trains are going to cross from one line to another. As you can see here, there's some insulated points or insulated rail joiners or fish plates, and likewise down here we also have the insulated, and these are insulated just plastic, and as you can see they keep the rails separated with a small notch of plastic there. And it might be easier to see here on this one. We'll zoom it in. It's lost focus. There you go. You can see the little gap between the tracks with the plastic piece and the plastic piece of rail, and that's basically to prevent the rails from conducting electricity from one section to the other. And if you have it set up properly, the train will come over here. It'll be going fast enough that its momentum will take it onto this set of tracks. And like I said, as long as these and these are wired in the same polarity, you have to set the controllers in the same direction and roughly the same speed, and when the train traverses this track onto this, it'll just keep going. So finally, the rather useful sheet of paper that I have here is actually a track distance diagram. And so here you can see there's a minimum, a standard, and a maximum distance, and this particular figure here shows you the distance between the rails and so on. So for example, here we've got 31.5 millimeters, and it's the minimum distance between the two parallel tracks, the inside rails, and then 50 millimeters is from the center of both parallel tracks, and then from there to the side of an embankment is usually 21.25, and so it's actually up here for OO scale, and so you match the letters and so on here. So we'll post the link to this up on the website shortly, but this is indispensable. I use this and a small ruler to basically measure the track distances and try to get them as accurate as possible. And I know a lot of people like using track design software and so on, but the way I actually designed the layout was with a pencil and paper. So here you can see where we designed the kind of initial station and a couple of different tracks and so on, and how we envisioned the layout. And I obviously this is not the way it ended up being. I mean, we did keep a lot of the elements here, but the section here changed and the section here changed. And originally had the third rail on the inside track, but I moved the third rail to the outside track because there wasn't enough room for the overhead line equipment. For the masts, there just wasn't enough room based on this other diagram that we have here. There wasn't just not enough room for those masts to fit in here. So I moved I swapped these lines. So the third rail is now the inside track, goes from here down to the station, and then the overhead line will go on this third rail, or where the third rail originally was going to go. And obviously, this was just a loose design, and counted up how many left-hand and right-hand points I needed, how many express points I needed, and basically worked out how many trains were going to run on the track at a time, and figured out how many curves or how many points and what curved track I might need, and how much flex track I needed. And I just ordered a little bit more flex track than I actually needed to cover any changes that I made, and it's worked out pretty well. So what I did actually when this was done is I started with the outside track and worked my way in and made sure that the track fit, especially in the corner area here and over on the side here where the distance was only about 4 feet from wall to wall. But it worked out pretty well.